Welcome, welcome, welcome to CodeChat. Today's topic is just a little bit off topic, and that's a fun thing. As you probably know, we tend to talk a lot about web development and web technologies on CodeChat. But if you follow me, you know that I'm also really excited about hardware and IoT and all things maker. And today's topic is on that topic. And anymore these days, all of the technologies kind of converge. We're in a really exciting time, in my opinion. And today with me is Zoe from Shenzhen, China. How are you doing today, Zoe?
Yeah, very great.
Good. And we're going to be talking about some really fun stuff here. You work for Seed Studios. Can you tell us just a little bit about Seed and what you guys do?
Okay, sure. So Seed Studio is a company that provides hardware technology and engine manufacturing to help the makers to fulfill their ideas from prototype into a product. So actually we have helped millions of makers around the world to turn their projects into the products in the market now.
Okay, and you're talking specifically about the electronic part of the project, right? So
Yes.
if I've got some sort of a maker project and I'm laser cutting something out of wood and then I'm putting a little brain in it with some electronic components, you can help me with that electronic part, right?
Yeah, sure.
And how does that work? What do I give to you and what services do you offer?
So actually there are several parts that we can focus on. So let me give you an example. For example, like if you have an idea that you would like to take care of your plan because you're too busy, so you have the idea and then you go to a community like Instructables or Hackaday or Hackster.io, and then you find actually many people share the same idea with you. So you will go for their like recipes to see how you can make this project into a real stuff, for example, just like this.
Okay.
And then, so you will source the gadgets that can help you to build this prototype. So first, you need to have an idea. And second, so when you have this idea and then you make it into the ground, like you assemble some electronics and hand it to us, actually we can help you from these components into a PCB or PCBA that we can achieve. And third is, so if you think actually this is a very promising project because many of the community share the same idea with you. Actually, I need to take care of my plant when I'm busy, right? So you want to go to Kickstarter, and then you can give the project to us, and then we will offer you first is a suggestion how to improve in terms of hardware, software, mechanical, and also some quality control such as certificate.
Okay.
And then we will after the improvement, we can initiate the manufacturing for you.
Okay.
Yeah, and so there are steps by step that depend on what kind of level that your project are in, hobbyists or startups. So
Okay.
we can help both.
Okay, so whether I'm doing this for fun or money, basically.
Yes.
How many items are we talking about? Like, what if I just want one of these plant feeders for my house? Should I just make that myself with components?
Yeah.
Or at what point should I engage Seed Studios and say, you know what, I'd really like to make this easier to put together by creating a PCB?
So actually, we can help in many ways, and so maybe we want to share that actually open source hardware and hobby electronics is pretty fun. Don't be scared of the hardware thing.
Jump in.
Yeah. So for example, like if you are purely novice, you don't know how to start, but you have an idea.
Yeah.
So maybe go to Instructables or Hackster. There are many of the recipes that you can follow. They actually have instructions step by step. For example, so I do know Raspberry Pi is a good platform to start because actually it doesn't require so much on hardware or software, and there are clear instructions on the community that I have mentioned.
Yeah.
So, and then on the community, actually you can see, for example, like, okay, Raspberry Pi is a good platform to start. So, and then we may choose a Raspberry Pi that is here. And then because Seed Studio, we have a product line called Grove, which is like the electronic Lego, very tiny modules like we can see. Like I will show you.
Now this on top is a Grove shield on top of a Raspberry Pi, right?
Yes, that's true. Because Grove is good product to start because it's plug and make. So you just plug here, just like Lego, you don't need to solder. And so this is a growth, the OLED, and this is a slide. They're a part of it.
Okay.
So, so maybe let's brainstorm what kind of factors that you want to monitor the plant.
Yeah.
Carbon dioxide, oxygen, humidity, temperature, or any other like the moisture in the soil, right?
Yeah.
So actually you can find all this in the growth
There's
system.
sensors and all, for
that's
all of
true.
those things. Okay.
So for example, like, let's open it. So here there is oxygen sensor and carbon dioxide sensor.
Okay.
And then inside this one, this is supposed to tap in the soil to test the moisture.
Okay.
So for example, like, so you know what kind of factors you would like to involve, then actually the part list is settled.
Okay.
Yeah, so you need these sensors and you need these gadgets. And then the next step is, so what vehicles should we program or should we rely on to monitor this plant? So, and then we choose like Microsoft Azure to monitor this. So for example, like the IP shows that this plant is in Seattle. So it's fine. The moisture is okay.
It's okay for Seattle.
Yeah.
Okay.
So and then the plan shows like this, and it gives you, because this is in-house, so it gives you like, okay, your plan is well taken care of, and so the display will show here about the index of carbon dioxide, oxygen, humidity, moisture, something like that. And but 1 week ago it was in Las Vegas. So it's pretty dry. And Azure will tell Raspberry Pi that, okay, it needs some water. And then it gives the simulation like this. So it's thundering. And because there is a pump.
That's pretty creative.
Yeah, because there is a pump inside. And so the box actually, in the bottom there would be some water.
Yeah.
And the plant would be like here. And there is a humidifier here. I cannot take it down.
Okay.
Yeah, so it will give you some water to see.
Okay.
Yeah, so
it can pump some water into the plant. What if the gas mix is not ideal? Can it pump air in and out?
so because here is like
sealed.
open. This box is open. So the index actually would taken care of, like, but so far it's just pumping the water.
Yeah.
But actually you can. For example, I refer to your community to ask, because open source community, there is one advantage that you can ask questions and you can share with many people, so that how to improve this. And so it's all set. And Raspberry Pi now, it can be supported by Windows 10. So all the things actually we can run here by different vehicles that you want.
Yeah.
So basically, it's like you can follow the instructions step by step, and you don't need to worry about if I don't know quite well about hardware or software, what should we do? But actually, that is, what the charm it is in the open source hardware community.
Yeah.
You can rely on the community to know more about how the project goes and how we can improve that, and maybe the community members can give you ideas how to make this better.
In my opinion, we've got a couple of reasons why I might want to take on a project endeavor like this, because I could probably go online and find a device that's already been created, is commercially available to water my plants,
Yes.
and I'm pretty sure that I'm going to be spending far less on that commercial product than I am on all these components. But we're geeks and hackers, and we want to figure all this stuff out. So we want to put it together, and maybe it'll even be fun to put it in production in our house, and have our own plant watering system, and have these boards with wires hanging out, so that when people come over, we can say, I'm working on this fun project.
Yeah, that's
but
true.
then if I have a unique idea, something I can't find in market, like maybe it's a basic idea like a plant care system, but it offers something unique, like maybe it can handle the gas levels or something like that, and that doesn't exist. That's when I might want to bring this to Kickstarter, and I very well may be wanting not just 1 or 10, but 100 or 1,000 of these, right?
Yeah, that's true. So that's another level that SID can help the makers. Well, as you can see, actually now when we call makers, maybe bigger percentage of the makers are hobbyists, right?
Yeah.
So they make this for fun. But we think that, so first is like we need to make the level more accessible. I mean, we need to make the hardware more accessible to everyone because everyone can know more about it. And we think this kind of stuff actually are more like education. So especially nowadays, more kids and more schools are focusing on how to learn about the logic by this step-by-step instruction, and the kids can learn by themselves. And so this is the first. We want to make the threshold much lower than before. Everyone can access or everyone can design their hardware.
Yeah.
So this is the first step. And second, you know, everyone make their project. They may have some ideas about what their community needs. For example, like this product, so maybe it will represent a small group of people, though not all the maybe mainstream market of people that if you just water the plant, what about if I need to raise its oxygen level or gas level, right? So this may be somehow a demand from the niche market. But so far in the society, maybe the business would not focus on that niche market because it just represents a group of people. So that actually gives the opportunity, I mean, by hardware, by open source hardware, that we can help the makers or maybe just everyone, they can design their hardware. So when you have a demand, and you can make these gadgets to turn this project into a product easily. And then you can go to Kickstarter and with the help, for example, like everyone, for example, like actually you find the demand shared by the community. Actually, it's not just you only one thinking that I should think of like improve the gas level, but maybe actually several hundred.
Yeah.
And that is the business opportunity.
Maybe they haven't even thought of it yet. Maybe that would be great for their plants as well, but they just haven't thought of that yet.
Yeah, that's true. So, and the next thing is that, so how we can improve this, like maybe such a big thing into a consumer electronic. So many people would have many ideas, and SEED can help in the improvement of the design in terms of software, hardware, mechanical, as I have mentioned this. So, and then we can help the projects from the prototype into the product in terms of like improvement and manufacturing. So that's how SEED can help.
Yeah.
Yes.
So let me show you a product that I have here.
Okay.
This is TweetMonkey.
Okay.
And TweetMonkey is kind of an average toy with the batteries, and I've tapped into the batteries just so I can control him. If I tap these wires together, then he goes through his motions.
Yeah.
And I have a very, very simple circuit here. The whole idea here is to get people invited into this world of technology, so I don't want this to ever be all that complicated. So I've got an Edison with a little board with a basic GPIO, so this could really be most any processor. The Edison allows me, since I'm a web developer, allows me to write nodes, so that's excellent. But really all I'm doing is raising a pin up and down, and I've got a little circuit here. So this is where my mind starts going to Seed Studio. I've got a simple MOSFET and 2 resistors, and these are just basic components. These aren't even elaborate sensors like CO sensors and things like that. So what might I want to do with this entire circuit? What might I be able to do as far as productizing it or maybe just semi-productizing it?
Yeah, so generally if you can give us the Gaba file of the design, for example, like how the schematic runs, and actually our product managers or our engineers can help you to turn this into manufacturing very quickly.
Okay.
Or maybe there are some suggestions from our engineering team. Maybe in terms of cost down or maybe better like power management or consumption, they will give you some advice like maybe we can change the schematic in this way so that we can maybe better turn this prototype into a product that can be launched into the market, thinking of the cost down or thinking about like other components, better performance, and then after we settle down the prototype, we call it from 0.1 because we think this is a 0.1 product.
Okay.
So it's a prototype, and then we can, after our improvement, we will turn it into 1. That is
a product,
engineering.
An actual product. Yeah,
that is engineering sample.
Yeah.
And then we can better integrate this into manufacturing perspective. Yeah.
Excellent.
So in terms of this part, actually, we will have many products to support, especially when you are using something like this, which are actually open source hardware or hobby electronics platforms like Edison, and also these products like SparkFun gadgets. And that actually we can surely do, because what our goal is to, like, first we need to make more gadgets for the makers to make their products. And when they use these products, I mean, when I say open source gadgets, it's not only by C Studio, but also by like Adafruit, SparkFun, and other companies. When you use these gadgets to make your own product, we can very easily integrate these gadgets or prototype into our manufacturing.
Because you already know the components that make up those boards, especially your own. So Seed has a line of accessory sensors and base shields and things like that for all these major boards. And you already know what those are made of. So if I tell you I used the CO2 sensor and the LCD screen, you say, we already know how to turn that into a product, right?
Yeah, that's true. So we will improve this in two ways. So first is because we have our engineering team, that's R&D, and the second is we are manufacturing these gadgets, so we actually know the raw materials and each component very well. So we will actually help you in the integration very efficiently. That is the first. And second, so in terms of these gadgets, because actually it's for hobby mostly, and when you are turning this into prototype, that actually need maybe more much stronger performance in terms of the chipset. So for example, like actually we, so that it can help, because we have direct cooperation with semiconductor companies like Intel, Texas Instruments, so we know the chipset very well. For example, like if, like the Monkey, it may need continuous power support, right, from the battery. So we may tell you that maybe you can choose the Texas Instruments chipset to support this Monkey, so that it will maybe get more continuous support or operation. And we can tell you, for example, like thinking of this industrial level. And also, for example, like you use Edison platform, and then we will tell you because we actually provide an accessory line for Intel Edison, and then we can tell you by using Intel Edison, so you should know well about, for example, like its communication or also its working current, and then maybe you need to rearrange your components a little bit, something like that. So actually this can help can help the makers very well about turning their prototypes, and more important is to turning their ideas into a real product that maybe cannot be achieved in the past days. So I just want to reinforce something that Zoe said, and that is that if you're kind of on the fringe of the making an IoT movement, jump in with both feet. It's really a blast. It's not hard to get started. There's a lot of help out there. That's true.
The sites that you mentioned were Hackaday, Hackster.io, Instructables. These are all really good sites that tell you exactly what to buy and exactly what steps to go through. And it's a very multifaceted project in most cases, where like the plant feeder that we're looking at here, there's laser cutting, acrylic bending. There's LED lighting, electronics. You had to write a lot of software for that.
Yes, that's true.
So who knows which piece of that puzzle that you'll feel an affinity for. But
that's true.
And also down at the bottom of the page here on Channel 9, you can ask a question and just engage with the community. Ask Zoe a question or myself, and we can answer those. So thanks for the conversation today.
Cool.
Zoe, this is fun stuff.
Yeah, me too. Thank you.
All right, thanks for joining us on CodeChat. See you next time.
See you.